I mean, asset properties and how Postgres is achieving asset properties. And then we try to set up our lab environment. And this is my lab machine. Just operating system installed machine. It doesn't have any PostgreSQL related prerequisites, neither PostgreSQL software. So what we'll be doing on day one, we understood that PostgreSQL is just a piece of software, like any other software you download from internet, install it to create your database. So what I'll do, the first step, download Postgres. Go to PostgreSQL official site. Okay, before that, you have three methods of PostgreSQL installation. One is source code method. The second is package method, yum. Third is RPM method. You have three methods. So we'll start off with source code, then we'll see yum and RPM. So I'll come here, go to source. The latest version that is available is version 16. Open that. You have two types of zip files here. We'll see tar.zz. So right click on this, copy link address and download. wget, enter. This will download the PostgreSQL.tar.zz directly to your virtual machine.
In real time, we are using only the M only, right?
Real
Or
time 99.99% cases yum.
okay.
Download PostgreSQL software from internet.
So any difference we will see when we are installing via source code?
Yes, we'll understand that. Second, extract it. So I've downloaded tar-xf, your file name. ls-lrt, you have the file here. So I'm just extracting it. tar-xf. This one. Extracted, it has created a folder. These are my files, ls-lrt, present working directory. These are all my files. So before we install PostgreSQL, okay, I'll do one thing. I'll just straight away do /configure. It said something like this. See the last three lines. Configure error, no acceptable C compiler found. Right? So before we start installing PostgreSQL, we need to understand the prerequisites, or we need to install the prerequisites. First, ensure make is there. So how do I ensure make is there? Make -- version. This will tell me if make is there or not. Make command not found. What I need to do? DNF install make. Yes. So make -- version is to check. You should see make available at least 3.80. If it is not there, DNF install make. Yes. Make -- version again. So I got the output 4.2.1, which is above version 3.80. Number 2, check whether GCC is there or not. How do you check? RPM-QA grep GCC. This is the command you use to check if GCC is there or not. If GCC is there, you should see output something like GCC star. That means the RPM with the name GCC in the beginning. I don't have any such RPM with GCC in the beginning. So what do I need to do? DNF install GCC. Yes.
You explained, right? What is the need to have this make and GCC?
Yep. Done. See here. Where is this? Just remember this. When I'm trying to install my Postgres, it said no acceptable C compiler found. C compiler is nothing but your GCC. So just I have installed GCC, so I'll not get that C compiler not found error. But why GCC? We'll understand that later. If you are not getting something like that, then DNF install GCC. Next, third, check whether read line is there or not. Make GCC. How do I check? Read line. I should see two RPMs, read line and read line devil. What I need to see? Read line and read line hyphen devil. If I am not seeing them, read line star. So I have both readline devil and readline. And the last one is zlib. Check whether zlib is there or not. I should see both zlib and zlib devil. I only see zlib, so I'm doing DNF install zlib star.
In any flavor of Linux, we will be able to install all this, right? Directly without downloading the packages.
Yes, I mean in any flavor of Linux means
Prepared.
the package name remains same. The installation method varies. For example, if you take any Debian flavor or Ubuntu, there you get app install, apt install. But yeah, the package name remains same.
Okay.
Zlib. So I've got both zlib and zlib devil. Zlib. I need to see both. So yeah. And the last one, this is optional, which came in version 16 only. Until version 15, the fifth one, ICU library not required, but from version 16 it is required. Let me check. I need both dnf install lib icu -devel. Yes. Right. You need to see both lib icu and lib icu -devel. What do you need to do? lib icu star. So this is only version 16. If you are installing version 15 using source code method, not required. The fifth one. Okay, I'm done with prerequisites. Before I install my PostgreSQL, okay, I'll go to PostgreSQL ls-lrt. You have install file here. Open that file. This file tells you the installation method. So I'll go up. You have something called, where is it? Short version. So just download this. Copy, paste. So this is your short version of PostgreSQL installation. Right. So before installing, what I'll do, I'll go to documents. So some empty folder, whatever it is. Yep, the folder is empty. Let me try to create a sample C program. Sample.c. So what I'll do, just a hello world program. Hash include anyone from computer science background. Studio.h. Standard input output int main void, then printf hello world, then close. INCLUDESTUDIO not standard input output stdio. Nice. So I've just written a C program. I need to compile this C program. So in Windows you have turbo C, F9, F12, something like that. So in Linux, in command prompt, you need to run this command called gcc sample.c and your binary sample.o. What happened?
Hello, my double quotes.
Ah, nice. Right. Yeah, my compilation completed successfully. I have sample.o, the binary created. I need to run this /sample.o. I got my hello world. What if I have hundreds of thousands of C programs that I need to compile all of them at once and run all of them at once? In Linux, you can do that with a make. So what I need to do here is I just need to remove this. I'll remove this. I'll create a make file. Enter. In the make file, I'll have two sections. One is all, the other is install. In the all section, what I'll do, I'll write my compile code. In the install section, I will write my run code. Cat makefile. So in the all section, I have written my compile code. In the install section, I have written my run code. What I need to do here is just run make enter. When you run this make enter, it will go to this file and run all the lines that are there in all section. That means compile all your C programs. I'll do make install. It will run your run code. When you do make compile code, make install run code. And this is just compiling your simple single C program. Is this clear?
Yeah, yes, Kumar.
Yes. I'll go back to my PostgreSQL. What is the first step? First step is /configure to check whether the prerequisites installed or not. So what it is doing, checking for GCC option, whether GCC is installed or not. See here, checking for GCC, whether GCC is installed or not. In the same way, it will check for readline, zlib, lib, icu, or make. So it is checking whether all of these things are installed or not. When you don't see any error in the last line, earlier we have seen, right, somewhere, I don't know, while we were installing, okay, that's gone, I think.
It was giving some compiler not found.
Compiler not found. Later, when we installed our compiler, it worked. What is the second step? Make. Enter. So what it is doing? So it's literally doing what we did. GCC your .c .o. Go back, duplicate session, root. Make will take some time, at least 15 minutes. RAC 123, LSF and LRT. So I've gone to my extracted location. You have your make file here. Open that make file. You have a small shell that tells Postgres compiler to go each and every folder in the source code and compile all the C programs in the all section. So what my make is currently doing, it is going to source ls-lrt, go to one folder, ls-lrt, go to another folder, ls-lrt, run all these C programs. Go back, go to another folder, run all these C programs. So what is your configure? Check if prerequisites installed or not. . What is make? Compile your C programs. What is the use of make here? To compile my program. What is the use of GCC? End of the day, GCC is a compiler. Is this clear?
Yes, ma'am.
Yeah, Kumar Ilakya here.
Hmm.
Just to know, for prior installation of this Postgre, whether that particular software doesn't have all the modules to be installed in a bundle way, or only for during the source code we are expected to do this prerequisite.
Perfect, correct. Only for source code. If you are doing
Okay.
yum and RPM method, you no need to see all these things.
Okay, yeah.
Only the M preparation only we have to follow all those things, right?
Not yum, source code preparation.
Oh, those good. Okay,
Hmm.
got it.
When you are doing it with yum, it is just like your executable, right? .exe, next, finish. Here you are literally compiling your C programs.
But it's too complex, like many steps we have to follow like that. That is also good. If you are if installing 6.5, we have to follow. If you are install 16, okay. We are going to install 16.5. Again, we have to follow all the things.
That is what, see, source code is like you are doing internal stuff. RPM is like RPM or yum, it is like you're on safer side, just executing your executable.
Automatically it will install all dependency packages, right?
Yeah, it will take care of everything, and it is easy to understand. A single command that will install your Postgres for you.
Okay. If you are writing any C shell program, you want to compile that this panel will be helpful, right? Okay.
If you are like let's say you want to modify your source code.
Oh, got it.
You got it right. You have got your source code here. All the source code. You want to modify this wall sender, how my replication works. So open this program, you write your own code or you modify it. Then you need to compile and run, which you cannot do with the yum method because you don't have access to source code if it is yum,
Oh, got it. Got it.
right? So source code is for someone who wanted to play with the software or who wanted to customize their Postgres installation, which we generally don't do in production machines.
Is it advisable to use a source code, or
No,
is it possible to go with the is how do you call that again? With
no.
the
I told you, right? Source code is not recommended in production machines. When I say not recommended, I tell it is easy for someone to install using yum rather than source code. So if you know what you're doing, if you know how you get errors, prerequisites, all that stuff, it is okay if you wanted to go with source code also. But people don't take risks. They want everything clean, 100% completed kind of messages every time. So they'll go with yum. We read, right? /configure. We have to read whether there is an error or not, whether there is a prerequisite that has not met or not. When it is yum, it is simple, 100% complete. That message you'll get on your computer screen. Done. Again, check in the last couple of lines whether there is any error or not. Okay. I don't see any error in the last 2 lines or 3 lines, whatever it is. Then make install, enter. Make install hardly takes a minute. This completes my installation. Again, same stuff. Check error message in the last couple of lines. I don't see any error message. So my installation has been completed successfully. I have installed my software. Why I have installed my software? I need to create databases. So when you successfully install your software, this is the location where your software goes, user local. Inside that you will have PGSQL, the software name. Inside that you will have bin. Inside that you have all your executable tools. So I'm done with my left hand side of that -d big line. Now I need to prepare my right hand side. For that, what I'll do, user add Postgres. I'm adding a user Postgres at operating system level who controls all PostgreSQL related activities. Then I'm creating a folder U01, which I wanted to use to store my PostgreSQL files. chown -r Postgres U01. I'm making Postgres as a user to this U01 folder. Then switch to Postgres user. Create a specific directory which you wanted to use for your database, to store your database files. Now, these are all my prerequisites. I'm done with my prerequisites. Or preparing my right hand side directory. Oh, sorry. Oh no. Make directory. Right. Now, cd usr local pgsql bin, the location where I have my binaries. Out of all tools, there is a tool called initdb, which will create database files in this location. Currently, this location is empty. So usr local pgsql bin initdb -d, your data directory. What it is doing, it is copying the required files to start your database. ls-lrt, you got your database directory related files. Now, simply start your database. ps-ef grep postgres, your database is started. Then to log in, there is another tool called psql, enter. So in this location, you have 3 tools. Tool 1, to initialize your first cluster. Cluster is nothing but a combination of databases. By default, you will get 3 databases. And this tool is to start your cluster. And this tool is to log into your cluster. So initdb, initialize your cluster. Start, then log into your cluster. Create a user. Not required. Self-explanatory. Any questions so far? So I've installed my version 16.0 in my CentOS 8. This is same across all Fedora flavors, Cent, Oracle Linux, RHEL, Amazon Linux, and so on. Yep, these are all my installation steps. Any questions?